This video will be an improvement to the dumbwaiter that I created, shown in the video above. On the initial build, I temporarily used a pulley and a rope to pull my stuff up and down. I had planned on putting an electric winch in to take care of this. But after using the elevator for a while, I decided, with the weight that I'd be moving, this would be overkill. So, instead, I installed a block and tackle system. This will give me a mechanical advantage of 4-to-1. Which means if I put 1 pound of force on it, I can lift 4 pounds on the elevator. For anyone that didn't watch my initial video, they're wondering, what is a dumbwaiter? This is something that allows me to move stuff up into my attic from my garage, or back down again. The operation of it is very simple. Place the object to be moved on the elevator, then use the rope through the pulley to lower or lift it. The disadvantage of the current design you're looking at is it's a 1-to-1 ratio. This means if you're lifting 60 pounds, you have to actually put 60 pounds of force on that rope. This not only requires a considerable amount of strength, but also a large enough rope that you can grab a hold of it. However, with a block and tackle that has 4 ropes going down to the elevator, I now only need to apply 15 pounds of force to the rope. This in turn allows me to use a smaller rope. So let's get started on this upgrade. First, I head to the store to pick up supplies. I need to buy a longer rope, and it can be smaller as well. In this case, 3-inch diameter rope, because that's how big my pulley wheels are. Since there's 4 rope lines going down to the elevator, the rope itself has to be 4 times longer than the original. Now, we also need some pulleys. Since I initially didn't know my block and tackle configuration, I bought a double pulley and 2 single pulleys. This allowed me to play with the configuration until I found something I liked. Next step, we need to build this support bracket that the pulleys will hang off of. Instead of going straight across like I did with my initial temporary support, I moved it up to the ceiling so that I could have more room for the pulleys, as well as more room to put in mounting bolts. I cut a piece of paper to the exact width between the 2 rafters, and cut my main piece of steel to that width. The steel I'm using is 4 inches wide and 1/4 inch thick. The perfect tool for cutting something like this is called the plasma cutter. It uses nothing but electricity and compressed air to create a stream of plasma as hot as the sun. Needless to say, when it comes into contact with steel, the steel never had a chance. Okay, the steel is cut to the exact width up at the roof level, but since nothing in my house is square, the lower edges of the rafters are closer together. I'll need to do a couple extra steps to deal with that. First, I cut this just a little bit shorter, which I will make up for when I cut these 2 end pieces. Cut the end pieces so they do not hang over the edge of the rafter. I'm using the same thickness steel. Something to consider is, before you weld these end pieces on, now is the perfect time to drill your mounting bolt holes. I initially forgot about these holes, welded the end pieces on, then says, oh darn. I did manage to drill the holes, but it was considerably harder. Now let's start out by tack welding these end pieces on. Since this is the side that butts up against the rafters, grind them down till they're smooth. This is actually a pretty weak weld at this point, which is good because we're going to head back up into the attic, temporarily mount this thing into place, and then bend those end pieces out till they match the angle of the rafter. When the angles are correct, you can do your final weld on the outside edge. When welding steel this thin, I've learned the hard way not to weld straight across. The steel will warp. So I go back and forth welding little sections at a time, giving it a little cool-off time in between. And suddenly you realize you don't have warped steel. When the outside edges are welded and ground down, throw some support welds on the inside edges. No grinding necessary here. Remember the mounting bolt holes I told you to drill earlier? A drill press makes this a pretty easy job. I found that using cutting oil makes it much easier on the drill bits as well. Okay, the easy part's done. Now let's take a look at this. Notice those ropes have to come down the exact center of your hole. Since the roof is at an angle, and you're moving the support higher up, This means that your support will be in a different location than your temporary support. Use a level to extend the line from the rope straight up to the roof, and mark it. You want to mark it in both axes. As a secondary backup check, I also marked off where my temporary support was and took it all the way up to the roof. Okay, theoretically, right here is where my rope should come down from my pulley. This is how thick my pulley support is. Alright, here's the next problem. The actual pulley is hanging down below that support at an angle, so I don't know where to put it. My solution? I drill a whole bunch of holes and temporarily wire support into place. This way I can temporarily mount my bracket, hook up the pulley, and see where it hangs. I can move it forward and backwards as necessary. An astute observer will notice my ring goes side to side. The first time I put it in place, I realized it should go fore and aft. But that's okay, those holes work both directions. Who's our favorite customer? That would be rework. Once you know exactly where that ring belongs, weld it into place. Remove your temporary wiring. I painted the bracket high visibility red to call attention to the fact you can hit your head on this thing. Or at least that hook that's hanging down. Bolt your new bracket into place. Hang your pulley from it. Sorry about the horrible photography job. Then route your rope. Let's take this thing out for a test drive. That's pretty awesome. Everything fit the first time. Now I need to stress test this to see that if it will actually work under load. I put 60 pounds on it, which is about twice as much weight than I ever use on this elevator. And it was extremely easy to lift. Heck, if I had kids, I could send them up to lift this thing. It only requires 15 pounds of force. I then allowed that load to just hang for 24 hours. This both verified the integrity of the elevator platform and pre-stretched the rope. The pulleys I eventually wound up using was the double pulley up top and 2 single pulleys down below, because that's what I happen to have. Notice they're mounted at different heights so they don't interfere with each other. But it would be better to replace it with a single double pulley. That's about it. As a final step, verify that the markings you have on your floor that tell people down below where to stay clear of are still nice and visible. Well, thanks for watching.